Hello again, everyone. This video I'm going to be going over the solution to the third eLearning free response question. This one involves a paragraph length response, which if you've looked at the information that was put out by College Board recently about the changes to the exam, you will have seen that now the exam is going to consist of just 2 free response questions, the second of which will be a paragraph length response, and it will comprise 40% of the score for the test. So I'm going to make sure you get plenty of these to practice on. So this one actually has a small part before we get to the paragraph length response question. So first of all, the setup here is that we have a robot that fires projectiles in some sort of competition. There is a set of different zones marked out in front of the robot, which are each worth a certain number of points. And there's a target at some specified distance d, which is worth the maximum number of points. And we're told that this robot is calibrated such that if we fire from a specific height h with a specific speed v0 or v0, then the projectile should land precisely on the target. So the first part of the question, they want you to fill in these 2 graphs that show the horizontal and vertical components of the projectile's velocity after it's launched. So the thing you need to understand here is that the horizontal and vertical motions of this object are independent of one another. So when this thing is launched, it starts with a certain horizontal velocity, and the horizontal and vertical velocities may or may not change over time. All right, so what would cause the velocity in either the horizontal or vertical component direction, to change? Well, if the velocity changes, that would be an acceleration, and an acceleration requires a force. Right, so this is just some general kinematics review here. So change in velocity, that's the definition of acceleration, and acceleration requires a force. So after this thing is launched, the only force that's acting on it as it travels through the air is gravity, and gravity only acts in the vertical direction. So that means in the horizontal direction, there is no force, which means there is no acceleration, which means the velocity is constant. So this thing will have some initial horizontal velocity, and that will remain constant throughout the duration of its motion. It doesn't matter where you put this horizontal line, just have some sort of horizontal line at a positive non-zero value. In the vertical direction, this thing actually starts with no vertical motion because it's fired horizontally, but there is a downward force, which is gravity, so there is a downward acceleration, so the velocity is going to decrease. Notice this problem specifically defines positive directions for us. So in the vertical direction, up is defined as positive, so as the projectile starts to move downward faster and faster, that's going to be a negative velocity. And since the force is constant, also, we have a constant acceleration, which means we have a constant slope to this graph here. And again, it doesn't matter what you make the slope. It can be a big slope or a small slope. There are no numbers on these graphs. So as long as you have a straight line, the negative slope that starts at 0, then you have a correct graph. Okay, so now the main part of this problem is the paragraph length response. So you're told that something goes wrong with your robot, and instead of firing at a height h, it can only fire from a height h over 2. But you can select 2 different speeds. You can either fire it at the initial velocity, or you can fire it at exactly twice that velocity. Nothing in between, just one of those 2 values. So you're asked to choose which of the 2 speeds to fire at and to defend that choice. All right, so there's a bit more to this one. So how would we think about this? So first of all, we want to think about how far the projectile would go if we fire it at the original speed, but from half the height. So some things we can say without too much difficulty. If we fire from a lower height, then the projectile is going to hit the ground faster or sooner because gravity will still affect it the same way. So since we fire from a lower height, it will have less time in the air, and if it has less time in the air, if we fire it at the same speed, then it will travel less distance. And that's if we fire at speed v0. All right, so can we say anything more specific than that? So how much time will it spend in the air exactly? So one thing you may remember from kinematics, if something is launched horizontally, it's going to land in the same amount of time as if it is just dropped. Remember that demo that we did really early in the year. So if something is just dropped from rest from some height h, the distance that it falls will be equal to 1/2 g times t squared. Or said another way, t, if we solve this equation for t, will tell us the time that it takes the object to fall some distance h. All right, so if we rearrange that, t would be 2h divided by g square rooted. Okay, so what happens if we decrease the value of h by a factor of 2? If we decrease h by a factor of 2, t is going to decrease as well, but since h is inside a square root, t will decrease by a factor of the square root of 2. So it'll be its original value divided by the square root of 2. That'll be how much time it takes to land if you fire from half the height. Okay, so if we fire it with the same speed from half the height, the distance it travels will also decrease by a factor of square root of 2. So, land somewhere over here. Turns out 1 divided by the square root of 2 is about 0.7 times the distance. You don't need to necessarily know that for this problem, but it's somewhere between 1/2 and 1. Okay, so if we fire it at the same speed from half the height, it's going to go a smaller distance, bottom line. All right, so another thing we can say is we cannot hit the target since we only have 2 speeds to fire at, so we just have to decide which of these 2 speeds is going to maximize our score. All right, so if we fire at the initial speed, we're going to land short of the target somewhere in this 2-point zone. If we fire with double the speed, that is going to increase the distance. It will double the distance that we would fire at the lower speed, and that's going to land somewhere over here in the 3-point zone. So if we fire at 2 v0, then we will land in the 3-point zone, so that's the speed that we should use. All right, so I gave a little bit of extra stuff in this problem here. You don't need to go through these calculations. Maybe citing this equation here, h equals 1/2 gt squared, might be beneficial, but the main things they're looking for here is some understanding that if you fire it from a lower height, it's going to hit the ground in less time, therefore it's going to travel less horizontal distance. And then since we only have 2 speeds to choose from, you do have to recognize that firing at twice the speed doesn't exactly cancel out firing from half the height. So you do need to recognize that firing at double the speed will not make you hit the target precisely. And that's because if you look at this equation here, decreasing the height by a factor of 2 does not decrease the time of flight by a factor of 2. It decreases by some other factor. So there is a little bit of analysis you have to go through here. So once you realize that it's not possible to hit the target, you will end up with a choice of either landing short of the target or landing beyond the target, and you get more points firing beyond the target, so you should fire at the higher of the two speeds that you have to choose from. Okay, so that's pretty much all there is to say about this problem, so thank you for watching.